So today I'm going to talk about AI, but actually embedded in road vehicles, so embodied AI in a cyber-physical system. And with that comes a lot of different complexities, and I'm going to give you some of those perspectives today. And I'm going to talk about engineering AI ethics by design, what we call it, and also will make a strong reference to standards and regulations, and hopefully draw your attention on how you potentially could choose to get involved with that space that's very dynamic for the AI sector today. So I'm Paula Palade, and I am an AI ethics and safety senior technical specialist within Jaguar Land Rover. My career started really in academia many, many years ago. I did my PhD at the University of Nottingham in something that was totally not linked to the automotive industry at all. I worked on radio frequency and microwave applications for industrial high power applications for many different industries, such as mining and chemical industries and oils and drill cuttings. And as a result of that short-lived academic career, I have a couple of patents, but then I quickly found out that academic career doesn't really marriage well with industrial work, so therefore I decided to leave academia and join industry. So I joined Jaguar Land Rover in 2014 as an electronics engineer, ADAS engineer looking at intelligence systems, and that's where I became acquainted, or I discovered a gap, and maybe this is where my academic background helped me to discover a gap on the ethical questions around autonomous vehicles. And that was very early days of this topic, so there wasn't really much in the world in terms of guidance on how to approach this topic. So I mostly used my interest in the topic and maybe some of my academic kind of background, and I started looking into this as almost like a pet project, like, an interesting project. And maybe because I had a strong profile with the European Commission already, I was invited to be part of one of the first expert groups at the European level to write for the European Commission the position paper on ethics for connected and automated vehicles. And this happened in 2019, I remember being pregnant with my second son, and initially I didn't want to do it because I wasn't a lawyer or an ethicist or a philosopher, so what would I know about ethical considerations of technology? But I was an engineer, so therefore I felt that my voice had relevance, and I decided to join the expert group. And I produced that report back in 2020. And that was when I started to feel comfortable to call myself an expert in the field of ethics, ethical issues for autonomous driving. Since then, I did a lot of other things. I've been heavily involved in standardization for the rapid movement field of let's call it artificial intelligence and ADAS, autonomous driver assistance features in vehicles. But I do a lot of things besides my career. I'm a mother of 3 young boys. I'm a school governor. I'm involved in my professional society, and I was very lucky to have won a couple of awards for the work I've been doing in this space. So I will try to give you a quick overview of what it means actually, and what are the type of things we are challenged with in the automotive space. And I like to start with this picture to frame it a little bit. Anyone in the room knows what this picture represents or what it originates? I see some notes here, so please do share.
When you first had cars, you had to have a man walking in front of them with a red flag to warn everybody else it was a car.
Excellent, perfect explanation. Thank you for that. So effectively, this is one of the first one of the legislative acts that was introduced in Britain in 1865, I believe. It's called the Red Flag Act or the Locomotive Act. And effectively, it said that in order to have a motorized vehicle on the road, you had to have a person walking, I think, 60 yards in front, waving a red flag. And you also had the first speed limits. You had 2 miles per hour in towns and 4 miles per hour outside towns, and a £10 fine for breaking that speed limit. So it would put you bankrupt, effectively, in today's money. And that legislation lasted for 30 years before it was abolished. Now, obviously, there were a lot of investors that had investments in horses, carriages, locomotive. They wanted to hinder the application of this technology. But I want to make the point that we are reliving a similar time today because society was also skeptical about the adoption of this technology. And with the introduction of automated vehicles on the roads today, we are living a similar time. We need to make sure that whatever we deliver in whatever technology, be it automotive or anything else, needs to be done with societal discussion and acceptance in mind of that new technology. And that's where the topic of ethics of automated vehicles come into play. Now, you might think Britain is a funny place like that. We had a law that lasted for 30 years. But there were laws like this around the world. As an example, in Pennsylvania, there was a piece of legislation that was written that said if you were driving a motorized vehicle on the road and you happened to encounter any livestock or horses or any cattle, you had to quickly dismantle the vehicle and hide it in the bushes so the animals don't get frightened. So it can be worse, okay? So now when we talk about the topic of ethics, what do we mean? And this is something that everyone draws to this kind of example and question, really. This is, everyone knows about the trolley problem. Now, just a show of hands, how many of you have heard about the trolley problem before? So quite few of you. So the trolley problem has nothing to do with vehicles, really. Doesn't originate from the automotive sector. It's a problem that's well known for many hundreds of years. But the application of the trolley problem goes like this. You have a trolley running on the track, or please replace it in your imagination with an automated vehicle driving down the road. If you don't do anything, the vehicle will keep on going and hit 5 people on the track. Now you have the opportunity to pull a lever and divert the trolley or the car, and therefore you can save the life of the 5 and just kill the 1. So what do you choose to do? And this is a very simple kind of experiment, and there are plenty of those type of experiments that are carried out there. So let's see in this room, what will you choose to do? How many of you will choose to pull the lever, divert the carriage, therefore save the 5 versus the 1, which is called an utilitarian approach? Don't be shy. You're on camera, but that's okay. So approximately half of you. So I would say statistically relevant. I think research shows that about 80% of people will choose to pull the lever and divert the carriage, therefore save the 5 versus the 1. But actually, when it comes about engineering such vehicles, the question is not that easy. And this type of questions, do you kill the 5 versus the 1, the man versus the woman, the cat versus the dog, the different variations that we have in the literature, for those of you that know about the moral machine study or the elderly versus the young, they don't help us design better and safer products, right? We need actually robust engineering requirements to do that. So therefore, while this is a very nice discussion to have down the pub, it doesn't help us or bring us closer to actually how do we engineer better products, whatever those products are. So the questions we need to ask ourselves are, how are we creating a safe AI framework and make sure that AI ethics and safety, because safety is one of the key ethical principles, do no harm, are embedded in the products we create. So we need to take the abstract concepts and qualitative KPIs and translate them down into clear engineering design frameworks and quantitative KPIs that we can measure to make sure that our products, in my case, vehicles, have those societal and ethical values in the products we generate. By doing that, and by capturing AI ethics in the system design requirements, only doing so we can guarantee product integrity and compliance as well. Now, I want to give you a little bit more in terms of when things go wrong and can we actually start moving the discussion a bit further from the ethical trolley type problem dilemma. So I'm going to speak a little bit about the EU report that I mentioned. That was my first kind of interaction with this space. So the European Commission really wanted to have a position paper that enabled it to drive its policy agenda, but also its research and innovation agenda in terms of how should it tackle the questions around ethics for connected automated vehicles. It acknowledged that new technologies, they don't just happen, but they are designed by people, and therefore they will have ethical values in the technology themselves, and they needed to ensure that they had ethical use, positive impact, acceptance, societal acceptance, and trust. Because without these things, those technologies will never materialize or realize the benefits we hear about, right? Reduce congestion, increase safety, and many, many other things. So the recommendations we came up, and the report is publicly available, it has a lot of discussion behind it, are 20 6 for safety, 9 for transparency, data and algorithm ethics, and 5 for responsibility. And I'm sure some of them, as you read them, you'll see they apply in many, many different sectors. They are not specific to road vehicles. Such as auditing algorithms or AI algorithms, or reducing opacity in algorithmic decisions, or potentially promoting a fair system of attribution of moral and legal culpability, but also actually looking at data sets and protecting data sets, and also we could look at increasing literacy in this space. But if we specifically look at safety for road vehicles, that's very important. And I want to give you, in the next video, you'll see an example when things go wrong. As an example, recommendation number 3 says, define clear standards for responsible open road testing. And in the automotive space, we have a lot of accidents and issues where these systems are tested and people are killed or injured. So there are a lot of things that go wrong. And I want to share with you an example, which was the first recorded pedestrian fatality in Arizona on an Uber vehicle, to understand why having recommendation, guidance, and policy papers like this are very important. So I only have 5 minutes, so I'm going to not rush, but kind of try to provide you a little bit of an overview of the things we do in the space to make sure that whatever we put on the roads, not only my company, but all companies, we do so safely and responsibly. So there are regulations that are starting to be written from UNECE, and the automotive industry is heavily regulated, so that's very good for us, but also a limiting factor because we need to wait for regulations before we can put the technology on the road. So therefore, I am privileged enough to be part of actually writing some of these upcoming regulations for AI use in automated vehicles and on-road vehicles in general. And I would like to also encourage you in your space, are there opportunities for you to get involved in regulations and standards authoring? Because I think it's a fantastic, fantastic space to operate and bring your technical knowledge, but also contribute together with other industry experts to advance the state of the art. When it comes to AI and regulations and standards, there are two different things. Regulations are compulsory. They are the minimum thing you need to comply with in order to put your product on the market, whereas standards are voluntary, they are market-led, and they demonstrate industry best practice. They are mostly open and consensus-based, so totally different, right? Now, how many of you in the room have heard about the EU AI Act? Most of you, yes. So the EU AI Act is a piece of regulation that comes from the European Union, and it's going to regulate all AI systems, regardless of the domain. So it's a cross-sector regulation, and obviously it will have high-risk systems. So it's industry agnostic, so everyone should be aware of it if it uses AI. And in order for the EU AI Act to be brought into force, it's pointing to a variety of standards. Most of these standards are not published yet. And these standards are going to provide that set of conformity assessment for the compliance with the EU AI Act. So again, standardization is very important to show that compliance with the regulatory framework. And there are many other standards. I just have a collection of standards here for you to look at. I'm not going to name them at all, but as you can see, they are very wide and very diverse for the AI space. So definitely something that I would encourage you to have a look into if you are not doing so already. What is applicable to you in your domain and sphere of work? For us in the automotive domain, we are very well regulated. So we have a clear standards that we have to comply with, clear regulations, and clear specific standards for the automotive space. But this is where standardization becomes even more important for me and my career. Now I serve the head of the UK delegation for a new standard on safety and artificial intelligence for road vehicles. And this standard is building on other previous standards, such as functional safety and safety of the intended functionality in road vehicles. And we are going to define on how we should implement artificial intelligence safely in all the road vehicles for anyone that will comply with these standards. So it's going to be very instrumental, and I'm very happy to be part of that development, but actually also to write some of the regulations in this space. Now, there are many challenges in AI safety, and I don't have time to go today, but I want to show you a quick video that the standard that I'm creating will help to mitigate against. So in this video, you'll see has as a stop sign has been mistakenly recognized as a person due to an adversarial attack. Okay, so many things can go wrong in the space of AI in vehicles. And I have another short video for you before I conclude. So in this video, we have a speed limit of 90 kilometers per hour that was projected on a building, which caused the test vehicle to have braking alerts. And you can see here how many different things can go wrong. So the attacker projected a 90 kilometers per hour traffic sign on that wall. You can see it in the video. And a car equipped with some advanced driver assistance system, it's entering the scene and is reading that sign on the wall. So you'll see that in a second. So this it considered it to be a real traffic sign, and the speed limit in that area was 30 kilometers per hour. So this is the next level up of those ethical questions that we started at the beginning, the trolley problem, yes, that were very simplistic. Now, what would happen if an attacker projects a no-entry traffic sign along a route of an autonomous car driving on a highway at 120 kilometers per hour, as an example? And this is where we are starting to see some of those ethical questions and implications in practice. So therefore, to conclude, we need practical and clear requirements in order how to avoid some of the safety implications when it comes to AI in a cyber-physical system in autonomous vehicles. But I'm pretty sure that also for all of you in the audience today, regulation in AI will become a big part, and standardization as a part to enable that regulation to take place will be very important. So I would encourage you to have a look at that. Thank you.